Pack 7 QA fundamental session, orientation. This is like a second orientation session that we're trying to do. So to get you again a clear picture of what you're going to learn as part of this, there is a main JPACT orientation. If you're not really clear of what is this program, then you should definitely watch the JPACT orientation, which Karthik has done some time back. This is more of QA fundamentals orientation, what we're going to do today. But the overall program orientation is already there in the website. So it's basically related to the job placements and certification training. And in that, we have different modules that we're going to deal with, starting from the QA module, then we get onto automation. In automation, we're going to deal with different tools. Even in QA fundamentals, one is like manually creating the test cases, manual test execution with the project work, and then using few tools like HPLM or Jira. One of the tool will be definitely using it, and we have trainings available for other videos. Then getting on to learn any programming language like Java or Python or any other programming language that you feel important. And if you ask us a suggestion, Java should be good enough to start with automations. So then you will get into automation. And yeah, so that's how it goes. And after that, you do a project work on manual, do project work on automation, develop frameworks, and then you would be kind of ready for applying the jobs. And that's when we will try to analyze the skill gap, that what you have and what is required. The trainings, we will already be definitely filling the gap, but again we'll do a one-on-one skill gap analysis, and then we will help you in kind of finding the jobs. Meanwhile, while doing all these things, you can even think of certifications like ISTQB certifications that will add value to your profile. So that's the overall program. And in that, the first module is more of QA, the QA, or I would say the fundamentals of QA, or you can say manual testing. Because at any point of the time, before you get onto automation testing, learning automation, be it with Selenium, HPUFT, or any of the tool, you need to be really, really comfortable in what is manual testing is all about, and what kind of job expectations will be there for a manual test point of view, so that you should be really comfortable. And even this, I have done a session 1 few days back, I think last week. So you need to definitely watch the session 1. It's a continuation from there. And today what we're going to do is on session 2. So if you, again, just a quick recap of 5 minutes on session 1, I kind of touched upon the topics that you should be really be learning, like software development lifecycle, or what we call it as an SDLC. There are different SDLC models, like classic and still very popular is the waterfall model, which very few companies use it now. But the latest and most of the companies adapt is Agile. So we're going to spend a few minutes today understanding the waterfall, and if time permits, we'll get into Agile. That's the first component. Then we'll talk about the different roles and responsibilities of you being a tester in and in this software development life cycles is the major criteria that we should know. Then we'll get on to writing deliverables like test cases, test scenarios, preparing test data, and we use a standard format for test case writing. So we do that. Then we'll talk about how do we perform the execution. While performing the execution, what kind of things that you should take care. And we we're going to talk about defect tracking or defect management. When you find issues, how you're going to track them, where you're going to track them, what is the format in which you're going to track it. So we'll see those formats. And then we'll understand what is defect triaging process, what is severity, priority when we log the defects. And it's not just about logging the defects. Is a tester job. It's not just about logging the defects. That was the expectation in the very beginning, but definitely not fixing as well. I mean, when I say don't just log, don't expect that you have to fix it. Fixing the defects is also not the expectation, but in between you have to really do some more analysis of trying to help the developer to fix it in an easy way, You have to provide a lot more information, exactly what configuration you tested, on what machine you tested, in exactly what scenario this issue is reproducible, what data you have entered, and is it only happening very first time or all the time consistently. All that information you have to do it, then only they'll value the information that you provided in the defect. If you just log a defect and say I did this step and I got the problem, then they won't see you like a valued test engineer. So you need to gain the value by helping our development team with as much information as possible. So that's what we're going to learn it in as part of these sessions. Okay. And then finally, we're going to talk about test reporting. How do you do the reporting? How do you say your test status? How do you project your defect status? All that information. So these are the different modules that we have to go through. So we're going to start with the first module today, that is more of understanding software development lifecycle. So let me just open a document. I'll put like SDLC models, and the very popular one, or I'm not really going into any specific type now. I'll just tell you the different SDLC phases, okay? Or I would say rather phases of SDLC. Is a font fine? Is it all visible for you? Phases of SDLC we're going to talk about. And with respect to the roles and responsibilities, this of QA. So we're going to mainly focus on the roles and responsibilities of QA in this particular area. Now, the most popular model, the most common model that is available for almost 30 years now, being successfully used in the market, is the waterfall model. And typically, what it contains is that there are different phases, like you'll have a initial phase where the outcome is something called BRS or BRD. I'll explain in detail about what is this and who will do it, what is our role and responsibility. So there is something called initial phase, in which you'll have a BRS or BRD's outcome. Then we will have a very important, and we all will be part of it, called requirements analysis. So then we will have something called requirements analysis. Here the outcome is that typically it will have a SRS, software requirement specification, or people call it as functional specification as well. Ideally, it should be both functional and non-functional requirements should be part of it. So I would prefer to call it as software requirement specification, but a lot of people generally call it as FS as well, functional specification. So that is what is going to happen. And then we will get into designing phase, design phase. And in the design phase, the outcome is high level design and low level design. So we'll talk about what are those and what is the difference between a high level design and low level design. So that will be the output. Then we will get into prototype phase. Prototype for any, typically the waterfall model is applicable for a larger projects where the projects used to run uh, 1 year, 2 years. I was in a largest project of about 3 years in my career. So that means the requirements gathering is started around like it was exactly 2005, and then it went on up to 2008. So the longest project that I have worked on was like 3 years. But today's world, it's not going to work like that. The even though it's a waterfall model, we generally do it in like max to max 3 months. We generally call it as like a quarterly release. Or the even though the model is waterfall, but people try to deliver it in like 1 month. That means you start the requirement gathering 30 days before, and you'll deliver it to the customer in like 30, 31 days. that is more like a mini waterfall, is what generally people also call it as. So in all those things, you will see these different phases of the life cycle, and we'll see where does a tester involve and what is our role and responsibility. Especially if you're doing a larger, a major UI kind of a project. Let's say you're doing a big e-commerce kind of an application, or you're developing a website, or you're doing, something related to customer facing and lot of UI screens. It's highly recommended to have a prototype. Prototype is nothing but it's a simulated copy of the actual system. So like before constructing a big building, right? The designer, in case of a real estate projects, obviously they'll come up with a design first. They will have a prototype first, and you'll obviously see it in their sales office and everywhere. And here is the complete picture of the building. Where does all things will come? Exactly in case of a software project, a prototype is going to take that responsibility, or people generally do a prototype, show it to their clients, tell you exactly basically this is how your project is going to look like, take a feedback, and if the feedback is needs to be improved, it's okay to improve on the prototype rather than the actual project. So that's why we spend some time and deliver prototype first. After that, we'll go into the development phase. Only when the prototype is successful, then we will go into the development phase. And during the development phase, the output is typically you will get a build or an exe file. In case of a Windows application, in case of web applications, it's more of a services component. So all these things put together. It could be something like a .exe file in case of a Windows application. It could be a .jar file in case of a Java specific, or in case of a web application, it could be some WAR file, or it could be something like a service that we need to deploy. So depending on the type of, or it could be something like a backend code. Depending on what type of application that we are building, there will be different components that gets delivered, but those are the outcomes of the development phase. And that too, I would say it is a unit tested. The outcome here is a unit tested build. Even though it sounds like a unit testing, this is the only one area which we are not going to involve as a QA. We are not going to perform any unit testing. Unit testing is the responsibility of the development team itself. Okay, so we'll talk about that more in detail, how exactly unit testing will be performed and what is the point of, what is the outcome of unit testing. But for now, you can think of the deliverable after the development phase is that by end of the development phase, you should get a unit tested build, which can be an exe or a jar or a, WAR in case of a web, or it could be some service or an API, right? Service or API. We'll talk about all these things, application programming interface, or it could be some backend component that needs to be deployed. And then we have something called, once the development is completed, so then we'll get into something called testing phase. This is also known as stabilization phase. So basically, right now what we have in the hand is a unit tested build. Unit testing is not a full-fledged testing. Unit testing is a very basic unit level testing that the developer performs. But there could be still a lot more issues in the system in terms of functionality, in terms of security, in terms of the UI, the graphical user interface, or issues related to load. It's not accepting the required load. Let's say it's an e-commerce site and supposed to handle 100,000 people, but below that itself, the system is crashing or not able to, it's hanging or not responding properly. Something related to load issues, or it's okay, it's handling the load, but the performance is like very, very bad. I'm like, I had to literally wait for few minutes after click on a link or click on a pay button to get the payment option. So those kind of performance issues are there, or related to accessibility issues. For example, we are expected this website to be available to all kinds of users, who has a proper vision, low vision, blind people, color vision. But right now, I don't see much of a help coming to blind people. So there is some accessibility related issue. So like this, we will have a different categorization of the testing. So to name a few, right? What you're going to do in testing or stabilization phase. This is fully our responsibility. So we'll start with something called integration testing. We'll do system testing, or it's also called end-to-end testing. We'll do something called functional testing, a load, performance, stress testing. We'll do GUI testing. We'll do usability testing. There are about close to 30 different techniques we have. Usability, security, we even call it like accessibility. Anything that you heard about it, API, I would say like, yeah. To start with, we even do something called sanity testing. It's not in the order, but we'll talk about them. You might have heard about something called regression testing, right? So there are many different techniques that we have, around 25 to 30 different techniques we have. It's not that in every project you do all of them, but depending on the project type. So what happens during the design phase is, one more important deliverable is HLD and LLD. And then we'll also have something called a master test plan, or we call it as MTP. So this is purely from the test side. We are going to prepare a test plan, and sometimes we do a separate, or in the same test plan we even create something called test strategy. So part of this, we will plan what to test and what not to test. So according to that, we will have a scope of testing, whether we should do all of these or we should do few of these, or in this case, let's say accessibility is an out of scope, or security is an out of scope, or load testing is not out of scope. So according to that, we'll define what is in scope and out of scope, and or whatever you planned in your master test plan, all of those you're going to perform during the testing phase or stabilization phase. And while doing this, what happens is that you will encounter some problems, you'll encounter some issues, you'll encounter some errors, you'll encounter some defects. So there are different names to it. People call it as bugs, errors, defects, issues. So I would not say they're all same, but at this point of the time, you can think of them are all same. It's just a different name, but as we go into details, we'll be able to differentiate what is an error versus an issue. Generally, programming related errors, we call them as errors, and anything that is deviating from customer expectation. Suppose in my e-commerce website, customer expecting I should be able to search a product category just by entering first few letters, and as it matches, it should be able to display. That is the expected behavior of the system, but the system has been developed in such a way that only when I enter a full name and click on the search button, it is searching. It's not more of a dynamic search. So what I'm going to say is it's a defect, because it's deviating from the expectations of what we wanted to do or customer wanted to achieve in the system. So such things, we call it as a defect. So as you are doing the testing, while you're doing the performing the testing, you'll encounter all these kind of things. So the next major thing is about defect, uh, I would say defect tracking or defect management. So the next important phase is defect tracking or defect management. It's very important. As you notice something not working as expected, as you see something there is a discrepancy, we should immediately report it. We cannot just leave it like that. It could be a major issue. It could be a big problem which will actually create a lot of revenue loss. So we need to really track it. And for tracking it, again, we're going to write different formats, or there is a particular format in which we're going to track the defects, or we use defect tracking tools like Bugzilla, HPALM, or Jira. These are some of the famous tools. So we're going to use one of these tools and we'll log the defects, and While logging, the tools will automatically takes a lot of information, and we have to provide lots of information like exactly what are the steps you performed, when did you get it, what data you have, what test data you have used. As I've been telling you, right? Is it consistently reproducible or it's kind of inconsistent? The biggest challenge with the defects is that it's reproducibility. If you are able to reproduce a problem, you are almost solving 50% of the problem to the developer. Because, and if you just say, no, I found the defect and I'm not able to find it now, then it's a big confusion state for the developer also. So we should help the developer with all the information exactly on what operating system you tested, what browser you tested, which version of the operating system, which version of the browser, what component you tested, what test data you have entered, how did you, what steps you performed. All that you have to give, because any one of this step could deviate, actually you might not get the problem. So in a lot of times what happens, you say I have a defect and your developer says, no, I'm not able to get the defect, it's working for me absolutely fine. So then what is the difference? There is a small difference of 10 steps that you are performing, 10 steps that he is performing. Even if one of the step is different, let's say you are performing on IE 11 and he is performing on IE 10, whole problem is different. You are performing on Windows 10, he's performing on maybe lower version of Windows. Again, the story is going to be different. So there are a lot of things that contributes for finding an issue. And we will have many different clients with the different combinations of operating systems and browsers and mobile devices. And again, when it comes to testing, is a big world. It's not about just testing it on your web application. It could be something related to the same thing. You might need to ensure it is consistent from different other systems that it is available. Today's world, all the e-commerce applications are available through web, as well as they are also available through app, right? So I might book an order from web and I may want to cancel it from app. Let's say I'm at home, I leisurely over a weekend, I search for an item and I ordered for it. And while I'm going to the office the next day or same day, I realize, no, it's not a good deal. I want to cancel it. So I should be able to cancel it from my mobile itself. So the consistency of all these things also should be taken care. Whether only you and your team is responsible for both web and mobile, or you have two different teams, one for mobile and one for web, that we don't know. But it's a big world, and you should be ready with all these different test case combinations for the interview point of view. At least when you go for an interview, if somebody asks you to if they come up with, hey, here is my website, here is my application, can you think of some test cases, you should be able to think through the very different types of testing that we're going to talk about. And that is through web, through mobile, and all kind of devices. And the future is all about IoT, Internet of Things. We are talking about, like, you might have already seen the Google Home and Amazon Alexa is kind of already helping as a personal assistant. So we don't know, tomorrow you might just ask, hey Alexa, do something in order for me in the Amazon website. It'll simply go and make an order for you in the Amazon website, or it might book an appointment in a hotel, or anywhere that you wanted to really take an appointment. So all these things are going to be a complete ecosystem that we are building it, and you should be able to think through all these end-to-end scenarios, end-to-end test cases. So, and the issue could be from anywhere. When you're working in mobile, it's absolutely working fine, and the issue is with web, or vice versa. It's working on web, but only with mobile. So we should be able to really, really nail down to the exact issue and exact reproducible steps. That is where our skills lies. People don't want somebody who can just play with the website and log a defect and say that my job is done. No, those kind of days are gone. People really want to recruit somebody who can troubleshoot it, who can really you know uh, debug, who can really go to nailing down to the exact issue, what you did and where did you get the error, so that you're almost helping the development team, like fixing the issue. You're not just writing the code, but you're able to help them. You may, I mean, there are many different ways in which we can achieve. For example, while doing a testing, you found an exception. What you can do, instead of just saying, hey, I found this exception, and instead of dumping the whole exception onto the bug, it's okay to do that. But you can also do an extra step. You go to Google and you search for the same exception, then you get some information. Oh, this is going to happen only in .NET applications of so and so version, and you can go and check it in your system what kind of .NET framework you have, and you can give the same information to the developer. As per my analysis, I think this is going to be only an issue with .NET Framework 3.5, and I'm using something like 3.x. Here are the details. So I think if you can take care of the latest version of the framework, it should automatically fix. You give suggestion, then they'll automatically value, oh, I mean, we see a different tester here. So that's exactly what is required and what we're going to learn from here. I've been talking it for a while, so just want to take it a pause and see if there are any questions before we move on. So any questions from anybody at this point of the time? Or is the length and the phase at which we are going is okay, or too fast, too slow, medium? Deepthi, you are exceptional because you do attend my automation training. So I'm just looking. I mean, yeah, that's good. Thanks. But any others, like team, you have any questions at this point of the time? Or should we just move forward? No, you did not really miss anything, Piyush. Exactly from QA point of view, this is an orientation session. We're doing it. And we have not even started with the actual topic. So don't worry. All right, so defect tracking or defect management is the main thing. So where you log defects or issues or bugs or errors, so there are different names to it. Okay, and while doing it, we'll talk about the differences. So, but as I told you, two things that I told you: any programming error that you get directly, which is not handled, right? You're getting as it is. For example, your developer did not handle it properly, and you're just directly getting an exception on your machine, or you're getting a 404 exception, or you're getting a 500 error. Such things you generally call it as an error. Anything that is deviating from your customer expectation. Suppose when I click on a link, something called pay link, it should open the payments page for me with the different payment navigations, credit card, debit card, etc. But I'm not getting that. I'm actually directly getting only credit card option straight away. So that is not correct. It's even though I'm able to complete my transaction, but that's not the difference, right? So anything that is deviating from your customer expectation, we call it as a defect. Okay. So, and similar people also call it as a bug, but issue is generally anything. Issue is like a very generic term. Uh, Initially it starts with issue. After you properly debug and after you properly analyze, it can either end up into a defect, or it's just like a one-time thing that there was some internet disconnectivity for a while, or it could be something like a server went down for a few seconds. So it starts with an issue, but it will either end up into a proper defect or a bug. And anything that's generally related to programming, we call it as a programming. So then it goes to something like defect tracking or defect management. We'll also do something called defect triaging. So you're logging the bugs, but actually it's not really a problem. For you, it was looking like a problem and you logged it. But when other people sit together and really look at the details of what issue that you have logged and what information, like your PM, your own boss, let's say test lead or test manager, and the project manager and the development team sitting together and trying to understand, they are not really feeling it as it's a problem. It's like it's absolutely fine, but for somehow you felt it like a defect and you logged it, but the rest of the team is not feeling like a defect. So they'll simply, all those things will come out in defect triaging, whether it is a defect or not. So the outputs of defect triage will be like deciding whether it is a defect or not. Also, what is the severity? Not every problem is of same severity. Like you will find some defects which will totally block your way. They're totally blocking the testing. If we give as it is the system to the client will throw it back. I mean, he cannot really do anything with the system. Suppose he's completely blocked during searching the items itself, and or he's not able to do anything on the system. He's completely blocked after login. So such kind of issues are like high critical, high severe issues. I mean, those things, it's not that every single defect that you find is of same category. So we generally categorize them through severity. Severity like 1, 2, 3, 4. Severity 1 means it's like highly critical. There's no way I can move forward, completely blocking my way, showstoppers on my application. So we generally categorize them. And those kind of issues needs to be fixed immediately by your developer. Within 24 hours, that needs to be fixed. Versus I have something like a severity 4, where there is a small spelling mistake on the label, or spelling mistake in message, or spelling mistake in a company name, or UI alignments are not proper, like they are overlapping on one on the other one, or the message is incorrect, or it's actually I'm getting a message saying order failed, but actually it's order created. So that's more like functionality work, but the message is incorrect. So such things are like severity 4. But if it is other way, I got an error message which is correct, but which is not supposed to create an order, but order got created, that is not severity 4. So there are different problems. So that could be severity 2 issue. So we'll talk about all the detailed severity, what is meant by 1, what is meant by 2, what is meant by 3 and 4. And we'll also decide at this particular time what is meant by priority, like how urgent it is. Priority will naturally come from client. If the client says it's urgent, that's it. If the client says, I'm okay, I can live with this for some time, then it will become like priority 2 or 3. So depending on how important it is to the client, we generally put it as priority. But severity is something like how critical the problem is. So that's about defect triaging or defect management. And then we'll go into deployment. After you really complete the whole testing, after the complete testing or stabilization is done, and then you have I mean, kind of going into a little more detail, if you just go into the SDLC phases, you'll have like initial requirements, design, prototype, development, testing, and this will be more of a subsection of that. Okay, defect triaging will be more of a subsection of that. And then you'll have directly deployment or installation. So you'll have deployment or installation of the code. So then whatever the build that you have received here, now that you have tested it with different components, with the different types of testing, and now you also log the defects and everything is fine. Finally, what you will do is you will sign off after all your test cases are sign off system testing, we'll call it as. After all the test cases are successfully completed, no more issues, at least to the knowledge that we have. Yeah, incident is also another term people generally use. So it's just like once in a while it happened, and I'm not able to really repro it. So since we cannot really dive deep, and we cannot really categorize that into a bug or an issue or any problem, so we'll say it was just like it's an intermittent issue. It's like a very inconsistent issue, or it's an incident. Yeah, that's a problem. So we have so many synonyms in English, so people use different things, and that's how these things will end up in testing. Okay, that's fine. We'll talk about again, with clear notes and the differences. But when anybody goes for certification, if you're really going for ISTQB or any other certifications in testing side, right, then you have to be very clearly be able to differentiate all of them, because there could be few questions on this itself. But when it comes to practicality, when you're really working in real time, does not really matter. You say error or you say bug, you say log, defect. So people will not really care about that. But from a subject point of view, from a concepts point of view, certification point of view, it's important to know those definitions. Okay, so once you do all these things, you'll do a sign off of the system testing. Because you are a quality gatekeeper, typically, if I have to explain where does your responsibility becomes more critical, is that uh, so here developer actually performs the development and unit testing in one environment, and we generally call it as a development environment, where he will develop it and unit test it. And that is a typically a different environment. You will not have access to it, only developers will have access. After he is comfortable and he feels confident, he will release the code, and that code will be deployed into something called system integration testing environment. Nowadays, we will just have only one environment called system integration testing, in which you will do integration testing, system testing, functional testing, or end-to-end testing. Everything you will do it here. Previously, in the previous days, before Agile came into picture, we used to have integration testing separate. We used to have system testing separate, like that. But now for the speed delivery, for the quick deliveries, we are not maintaining so many environments. But you will definitely have one environment for testers. Here, this is exclusively an access to the testing team. Your developer will not have access. If your developer will have an access, there is a highly chance when you report an issue, he'll say, I'm not getting it in dev, and let me see it on your machine. And if there is something that he can change it in his, the URL or the port number, if you just suffix with the port number, the problem will be solved. He can do that kind of magic here. I mean, I'm not saying that every developer is like that, but with a simple fix, he can make you to work it here. But actually, the problem is in the code he has to fix, and he'll actually fix it when the next time when there is a bug. So developer will not have access here. Only testing team will have an access. And then we will move on to, if you sign off, like after you do the system testing sign off, then there is something very important happens is called UAT. So there will be a separate environment called UAT environment, or you can call it as a beta. This is also called beta environment, where your customers, the end users, will perform user acceptance testing. You're not going to perform. There will be a separate UAT team from your client side. They will perform the user acceptance testing. But yes, if they get any issue, you are the first one to help them, because you are the one who recently performed everything and you signed off. And ultimately, so anything happens up to here is within the organization. It's within the organization. This is outside of your organization. It's like external client. It's on the client side. So who is placing the major role here is we are placing the major role as a quality gatekeeper. So anything goes beyond will be directly, we are responsible for it. So that's why you have a highly responsible job. And after that, what will happen? So after system testing sign off, it will be deployed into UAT. And after UAT gets successfully completed, if the UAT team says no issues, then we will actually deploy it into production. So this is production, or you can say the system will go live. The real users are actually using the system now. So anything after this is more like considered as client side. And why we spend a lot of efforts on the testing, and why we recruit exclusively testers, and why we have this exclusive job is it's directly proportional to the reputation of the company. It's directly proportional to the cost of fixing the bugs. If suppose, just to give you an idea, if a developer finds a problem, and if he himself identifies a problem, and if he himself will fix it, it might cost some 10 $20. Let's say somebody is working on, I don't know, it's a very less rate, I don't want to put it, like let's say maybe some $50. Okay, he found the problem, he realized the problem, and he changed the code by himself, and it started working. So it's all within the dev. So it could be something like cost of fixing the problem is like around $50. But the same thing if it is released to testing team, to a different environment, right? Now you have a separate testing team, separate environment. This code needs to be deployed here. Then you found a problem. Then you will report it into a central repository called Bugzilla or Jira. Let's assume Jira. So you report in Jira. It's a tool, and you give all the screenshots and everything. Then the dev will look at the bug. Then they will understand, and then they'll fix it in their environment. Again, they will have to do unit testing. Then again, they have to release the latest code. So anywhere the cost can go up to $500. This is still okay. The reason because it is still within the organization. We'll talk about how can we be more efficient in the next release or next sprint. And it's obviously a mistake from the development side. And that's why we have the testing team to catch it as a quality gatekeeper. So all that is fine. But anything beyond this is going to be a problem. So here the cost is already became $500 as an example. But let's say the testing team also did not find it. Then what happens? It will go to client. Now it's in a different environment. The actual clients are testing it. They found the problem. Then what will happen? They will report it. Again, they will also have access to Jira. They'll report it. When they report it, as a testing team, we'll go and check what is the issue they are reporting. We'll try to reproduce it in our SIT environment. Oh, damn, we are also getting it in our SIT environment. So it's a clear miss from our side. Then the developer will look at the issue. He will try to repro it in his machine, and then he'll fix it. Then again, he will give the latest code, which will go to SIT. We will again test it. Obviously, we'll be more and more careful this time. We'll test it, then we'll release to customer. So anywhere, I don't know, maybe $1,000, $5,000, I don't know. So cost can be increased exponentially. This is still okay. This is still okay because we are not yet live. We are not yet production. Because the moment it goes to production, there will be some hundred thousands different users. Think about very popular websites, right? So they're all going to use this feature. Even though I'm saying it is okay from an overall project point of view. Definitely, it's not a very good point from a testing point of view because the people will start questioning us after the project is over. During the postmortem, they'll ask you like, "Hey, why did you miss out this scenario? Why did you think of that test case as a whole team?" Right? Of course, there will be experiences, there will be learning and all that, but I'm just trying to put you into a very highly responsible situation. We definitely have a very responsible job. Let's assume if UAT team also did not find it, then what happens? We'll simply go deploy it in production. The bug was there from dev and SIT. We did not find it. UAT did not find it, and it gone to production. Now all these real users are using the system. Then they are all facing this. Maybe their account getting locked, their transactions not getting completed, their orders not getting placed, whatever. There's a major issue in the life. Of course, we hear a lot of times big companies do fail. It happens. I'm not saying that all the software that we are using today live are completely bug free. It's not that. But we'll try to avoid as much as possible. So let's say if there is a problem, then you can imagine the reputation of the company. You can imagine how many customers you may lose next time. So all that is going to really, really hit onto the revenue of the system. So anywhere, again, maybe 5,000 to 50,000. Sometimes whole product might get, you know, completely nobody is accepting your product. So many things will happen. So that's why the quality is very, very important. And all these e-commerce, banking, any other complicated systems are still okay because it's just a matter of money that is going to be lost. Obviously, the company will lose the customers and it'll gain at least another 1-2 years to gain the confidence back. All those things are still okay. Think about healthcare systems where you are actually testing a medical device or a medical application where it's actually going to give a report to a doctor saying here is the health condition of the patient and the total medication is going to happen based on that report, right? Think about defects in that systems. Think about critical space related projects. Maybe a software being used in an airplane or a software being used in a rocket. If there are any few fractions of seconds of differences in the performance will lead to so many different things, right? So just think about that situation where you're going to, I mean, it all depends on how critical application that you're going to work on it. The testing is going to be more important. This analogy is going to help you to understand how critical the job that you're going to do. Because I'm saying a lot of people think that, oh, testing, it's easy. Now, this is where, I mean, I'm not saying it's difficult, but I'm just trying to say you how important is your job. So when I say deployment, it's basically, making it live. Then after that, what happens? There will be another phase called maintenance, because anything that we do as a project and make it live, there is a warranty period of 4 weeks or 6 weeks, sometimes 12 weeks, depending on the agreement that they made. So anything that they get any issue within this warranty period will be fixed free of cost. And post that, typically all the projects, or again, we call them as a maintenance projects. And if after this warranty is over, if your client is asking for any ask, it is more of, again, we are going to charge for it basically. So it's going to be considered as a new enhancement or a new change request. But again, we will charge for it, and we'll again deploy it for it. We'll development and do it. In a way, if any new change request is coming from the customer, if a new enhancement is coming from the customer, it will go through all these phases again. It will be again analyzed. It will be completely requirement analysis is done. Design will be done for that. If required, prototype will do it. Then we do development. Then we do testing. And then again, we'll do all the elimination of all possible defects according to our knowledge. And then we'll do a sign off. After we sign off, actually, user acceptance testing, it's very important. User acceptance testing will happen. After they sign off, then it will go into production. Then again, maintenance. Fortunately or unfortunately, the projects that we have in the market, 70% of the projects you are going to work, we are going to work, or we are already working, are maintenance projects, mostly maintenance projects. You will get a brand new product or a brand new project which is very, very less, only like 20-30% of the projects are brand new project. But even though it's a maintenance project, every single change request you get, every enhancement you get, feels you it's like a project, a complete brand new project, because you'll have to go through all these phases. All right, so these are the typical phases, which maybe like your requirement phase may go for like 2 weeks in a typical project. Design phase may go for some 2 weeks. Prototype may be just like 3 days. Development might go for some 6 weeks, and the testing whole thing might go for sign off will go for like 4 weeks. UAT maybe for like 2 weeks, and deployment is maybe typically we try to do it on a Saturday, Sunday kind of stuff when system is not very active. So in a typical 3 months project or like 6 months project, it will be something of this sort. But what is happening in today's world is it's all agile. It's all nobody will have patience to have software getting developed for this much time. The almost the amount of time that I've put it will almost leads to 4 months. 6 weeks itself is gone for like 45 days, right? So even though it's a 3 months, if all things are going to come for 3 months, even nowadays no customer really wants to wait for 3 months unless it's a big project. Now it's all agile, and today's world what we are doing is we are doing the releases of 2 weeks, 4 weeks. Typically the max longest project that you do is 6 weeks project. And these are what is currently happening, and this is what we call it as agile methodology. And in agile methodology, what is going to happen is you get the requirements and you will deliver it to the customer within the 2 weeks of time or 4 weeks of time, or max longest agile is 6 weeks of time. But what is a different than how it can happen something that was for a 3 months, and how it can happen in like, or it was for a 6 months, how it can happen in 6 weeks is that we'll do it in an iterative model. Iterative model in the sense, see, ultimately, when we do the requirement analysis, we have identified that we have to develop 10 features. Feature 1, feature 2, like this we have to develop 10 different features. What are those? Maybe this is like registration of a customer. This is like searching for the items in the e-commerce application. This is like shopping cart. This is related to some deals and discounts, and things related to payments, things related to cancellation of the order, modifying an existing order, cancellation of a order, and finally we have some reporting, etc. So we have to develop 10 features. The previous waterfall model, all the requirement analysis used to happen at one time, and we used to come up with a very big document, a page, it could be something like 20 pager document or 30 pages of document with a clear explanation of each feature, what is the feature is about, who is going to use it, what are the prerequisites for this feature, how the screen will look like for this, and what an end user will do on this screen, what kind of inputs he can enter, what is output is expected. Everything was very, very detailed explained uh, in a document, and that document is what we used to call it as SRS or FS. Today in Agile, what we're trying to do is we don't do this much analysis of the requirement. We do the analysis of the requirement, but we don't do so much of documentation like this. And we don't do all at one shot. Rather, what we do is we'll do few at a time. Maybe in the first sprint, we'll take up only these two. And in the next sprint, we'll take up another two. In the next sprint, we'll take up like three. And last sprint will take up only one, because that is very complex feature. So we are actually dividing it into multiple iterations. Instead of doing the whole thing as one, we'll do one small cycle, then again one more cycle, then again one more cycle, then again one. Like this, we are going to do repeat all these multiple times instead of making the client wait for 3 months or 6 months. So we'll ask the client, out of these 10 features, tell me which are the, prioritize them. We'll ask the client to prioritize, and the client says feature 2 is the top most important one, so you should deliver this first. Then you deliver feature 1, and then you deliver this, and then you deliver this. So we'll prioritize, we'll sit with the customer, we'll understand, and we'll prioritize. And these are going to be not explained in a big pager document like this. They are explained it into single one page kind of a thing, and we typically call it as a user story. So it is going to be explained as a simple user story. It is named because ultimately user is going to use this feature, and when user use this feature, for example, cancellation of an order, as a user, how he is going to use that feature, that story needs to be explained. As an existing customer of so and so ABC commerce system, and I've already created an order, now my requirement is to cancel the order. And I may cancel it from a web application, may cancel it from a mobile application, or maybe cancel it from my a personal assistant device, etc. So you'll have those different categories explained, and the story will be described. The requirement is described like a story, and the story will have what is the uh, you know, expected criteria. We could generally call it as acceptance criteria. When you can accept this criteria, when the order is going to be cancelled successfully, when my payment is returned back into my account, at least payment transfer request has been initiated, because those banks and your system will take 2 to 3 working days to get your money back. So we are not, that is ultimately the end goal, but from a software point of view, we'll say when payment request transfer has been initiated, something of those, that's your acceptance criteria. So it's like explained like a user story, with a description, what is a prerequisite to perform, and ultimately what is acceptance criteria, when will you accept this criteria as successfully implemented. So that kind of user story kind of thing will be explained for every feature, and each user story will go through requirement analysis, a quick design, if required a prototype, then development, then testing, and UAT and deployment. So since we are not doing all these 10 features, we are doing only one or two or sometimes three or sometimes only one, but this time is fixed. If you confirm to the client that, hey, we will work in agile methodology and we'll give you release every 4 weeks, it's exactly 4 weeks. We'll never increase a day, we'll never decrease a day. It's always 4 weeks. We'll start on this Monday, so will the fourth Friday we will deliver it to the customer. But how much you can deliver is going to be different. In one sprint, you may do only 2 features. In one another sprint, you may do only one sprint. But because now the customer, we will give the cycle, so he will plan his business according to every 4 weeks or every 2 weeks. Most of the current projects are actually 2 week sprints. So that's the kind of a difference from a traditional waterfall model to the agile model. Because why people have to come to this model is things are changing very dynamic. Today, you think of some business solution. Tomorrow, there could be an announcement comes from a government of your country, or there could be some announcement comes related to tax related, or could be some business related, or there is a competitor who's plan. You came to know that there is a competitor is already working on this feature and you're planning to develop. So for so many reasons, nobody wants to go for a project of 3 months or a 6 months. It's totally of an agile. And in Agile, everything happens through user stories. And typically there is a Scrum team of 7 members. One is the duration. Like there is a question Piyush is asking how it is different from Agile to Waterfall. One is clearly duration. Duration from 3 months brought down to 3 weeks or 4 weeks or 2 weeks, right? That is the first point. The second point is scope. You could deliver everything at one shot in Waterfall. Here you're doing it into smaller chunks, in multiple iterations. And here, very big documentations, like requirements used to be a document, design used to be a document. So much of documentation was given high priority. I'm not saying no documentation in Agile, but it's less documentation. We'll do only as minimum documentation as possible. But from a testing point of view, uh, another concept that comes into picture, because you'll have a shorter duration of a time and you'll have to quickly test and sign off, automation is going to be a major role in Agile. So automation is a key in Agile. If you don't think of automation, then you're actually not getting fully ready for Agile. I'll explain even what is going to happen in Agile with automation, complete CI/CD. It's kind of people who are working in Agile model, they will have a daily builds. Every day there will be a new build coming overnight, and that build has to be tested overnight and has to be signed off next day morning. So when I say this 2 weeks, 4 weeks, 6 weeks, right? Think about these companies like Amazon, Google, Netflix, Facebook. They will have daily releases. Morning they will get a requirement, by evening they'll have to deploy. Sometimes they will have multiple releases in a daily manner. Because see, I mean, if they are thinking of one feature to be applied, and it's something for the a big sale that is coming up this week, or a festival season coming up this week, if they cannot do it by this week, they're going to lose a lot of revenue. They just got an idea today and the festival is next week, and they have to do all that before next week. That's it. So if they don't do it by next week, they're done. The sale is gone. So that I mean, one is it totally changed from only the company point of view? Not really, because 20 years back, 15 years back, we did not have supporting tools also. Like if I have to do a prototype, people used to do it on the papers. Today we have prototyping tools. You could just input something and you'll get an output. You could do it in your PowerPoint presentations. And for development and unit testing, people have to write the code and give it to other developer to do a review. Today we have static analysis tools, we have code review tools. So there is so much of change in the technology happen. Using all the technologies, we are trying to deliver as much as faster as possible. And that's where I'm talking about everyday night, your code check-ins, and compiles, unit test, system tests, user tests, deploys into production automatically. And this is what we generally call it as continuous integration and continuous deployment. So we are mostly into that environments where companies are doing daily deployments. Anyway, so we'll talk about all that as we go. Just from an orientation point of view, again, it's a second orientation. So QA is very important in terms of QA concepts. Manual testing is important. So we're going to start this, I think, from Thursday. Tomorrow is a holiday in India. It's Independence Day. So we're going to start from Thursday, and we will get on to a little bit more detailed discussion here. But we'll spend good amount of time here, which I could not do it. And then the second day onwards, when the paid session starts Thursday, first session we'll talk about this. Second session onwards, we'll talk about the deliverables. Deliverables like how do we write test cases, how do we write scenarios, how do we do the actual testing, manual testing, and how do we find bugs. So all that is going to be a key priority. All right. So any questions before we wind up? If you need any more details, you need to write an email to learn@iTeLearn.com. Learn@iTeLearn.com. Which tools we are going to learn this time. So this time, along with the manual testing, so we have all of them already covered. I'm not really decided anything, but definitely we will have something either Jira or ALM. Not really decided because they're all equally important. You learn one live and you'll have one go through videos. If you learn one, then you'll have to go through other videos. So something of that sort. But we already have, and if you want to learn both of them, we have the latest videos as well. So, but from a live point of view, we'll pick up one tool. Just to get a picture of how to write test cases, how do we write bugs, how do we write test reporting and everything. All right, so go with this for today from the orientation point of view. See you soon in paid sessions, that is from Thursday. And after the QA module, we'll get into automation. We'll get into frameworks development. We'll get into project work. That's when you'll be fully ready for trying out for the jobs. So you need to give some good 45 days to 2 months of time to become master in all of this. Good 90 minutes of session and then another 90 minutes of your practice work will make you kind of an expert. All right, team. So any other questions? You can look at our previous JPACT or kind of videos. How did we fill the skill gap analysis? Doing mock interviews. How we help people to place it in different interview jobs, etc. So that will kind of give you a picture of the whole program. You can request for a couple of those videos by writing an email to learn@itel.com. We'll give you a couple of sample videos to get you a picture of how the mock interviews we did, like myself, Karthik, and Ruxana was one of them. And the project work videos, you can request it. Automation videos, you can request it, sample. All right, so I'm not seeing any questions coming up. Thanks everyone. Thanks everyone for attending this. Talk to you soon. Have a good day.